Hello everyone, welcome back to Everything Swift. Today we are tackling Leetcode question 74 titled Search a 2D Matrix. A couple of weeks back, I did a part 2 of this question titled Search a 2D Matrix 2, so please feel free to check out that video as well. So let's take a look at what we have to do today for this question. We are given a matrix here, which is a 2D integer array, nested array, and we are given a target parameter here of type integer. Basically, our task for today is to find whether this target integer value exists inside this 2D matrix, right? So the few key properties that we are told from this question is that integers in each row are sorted from left to right, and the first integer of each row is greater than the last integer of the previous row, right? So let's take a look at this example. 1, 3, 5, and 7 meets the criteria as explained here. Integer in each row are sorted from left to right. 1, 3, 5, 7, 10, 11, 16, 20, 23, 30, 34, and 60, right? All of them are sorted from left to right, left to right, left to right, right? And the other condition is also telling us that the first integer in each row is greater than the previous one, the last integer of the previous row. So 10 is greater than 7, 23 is greater than 20, right? And in this example here, the target number is 3. And as we can see from this diagram here, 3 exists inside this 2D matrix, hence the output is true. The answer is true. So basically, pretty much straightforward in terms of what we have to do in this question. But the question is like, how do we go about solving this, right? The key hint from this question is basically this keyword here called sorted, right? Uh, Anytime when we see this keyword sorted, the first thing that we should sort of like raise our mind and try and think about is binary search, right? Anytime when we see this word sorted, whether it's an array sorted or in this case integers in each row are sorted from left to right, we should try and think like whether binary search can help us solve, whether binary search is basically the solution that we can use to solve the problem, right? So in this question, that is exactly what we're going to do. We're going to use binary search and break down this matrix and continuously try to find whether the target exists in this array. So what we're going to do here is we're going to find the starting pointer and ending pointer, and then we're going to compute the midpoint. Once we found out the mid value, we're going to check it against the target. If it's not matching, we're going to keep adjusting whether the starting pointer or ending pointer, depending whether we should increment or decrement to get closer to the target, right? Once that whole loop has happened, but we still fail to find the target, that means we can conclude that the target does not exist in the matrix. So it's a bit of a mouthful, but the gist of it is we're going to apply binary search and to solve this problem. So let's jump straight into the code and see how we're going to do that. As always, I'm going to check if the matrix is empty, and then I'm going to return false, right? So this is just a quick optimization here. Probably in the world of Leetcode, this is probably unnecessary unless specified in the question, but it's just a habit of mine where in the production or real world environment, this sort of fast exit function is probably helpful. But yeah, so essentially if the matrix is empty, there's no way we're going to have a target, right? So just return false. And what we're going to do here, I'm going to get the total number of integers in this matrix, and that is important for me to find out the starting index and ending index. So let's go ahead and do that. Matrix.count, and then columns equals to matrix of 0.count. So starting pointer is 0 and ending pointer is basically the size of this matrix, which is rows times columns minus 1. Minus 1 because we are dealing with index base, so we got a minus 1, or else we can get index out of bounds. What we're going to do here is we're going to look through and find our mid pointer and mid value. So while start is less than equals to n, let's compute our mid here. So mid equals to start plus n minus start divided by 2. So essentially I'm doing this formula to prevent integer overflow. There are some people that just do n minus start divided by 2, but some languages have the integer overflow scenario. So I'm just using this formula to avoid that. So that is to compute the mid index. Now we're going to compute the mid value. What we're going to do here is matrix of mid divided by column and mid modular columns. Once we find that, once we computed our mid value, we're going to check if mid value equals to target. If it is, then that's great news because we have found it and we can exit out from this while loop entirely because we have really accomplished our goal. However, if we fail to find the target, what we're going to do here is to check whether the mid value is bigger than the target or is it smaller than the target, right? So let's take a look at this example here and just pretend that this mid value is say 16, right? So in this scenario, mid value is 16 and the target is 3. So we know that any number bigger than mid value is not going to be our answer. Like 20 is not our target, 23, 30, 34, and 60 is not, right? And we can confidently know this because the numbers are sorted, right? So what we're going to do here is we're going to throw out all these numbers 20, 23, 30, and 34, and 36. And how we're going to do that is adjust our ending pointer because we know it's never going to be any of this integer. So we're just going to collapse the ending pointer. And we're going to do that by updating our ending end variable from mid minus 1. And the same thing on the flip side, if the mid value is smaller than the target, basically we need to collapse or expand or sort of like bring the starting pointer closer to it, right? So we're going to increment it, mid plus 1, right? So if this while loop doesn't get captured in this conditional statement here, that means we have failed to find the target within this matrix. So we can just return false here. Yeah. So that looks about it. Let's go ahead and try and submit this and hopefully get it right on the first try. There we go. Looks good. Let's try and submit this. And there we have it. That is the solution. We succeeded. But yeah. So basically, just to recap, the keyword sorted gave me the hint that I can try and use binary search to try and solve the problem. And basically how we compute that is basically getting the starting and ending pointer, and the ending pointer in this problem here is the size of the matrix here that I computed from the rows and columns minus 1 because it's index. So uh, that's why I did minus 1 because it's zero base index. And then I did the while loop, and in each of the iteration I find the mid value and just compare if the mid value is equals to target. If it is, that's great news. If not, adjust the ending and starting pointer. If we fail to find the mid value, basically the target does not exist in the matrix and we can just return false. So yeah, hopefully that explanation helps and you guys find it helpful. And as always, please feel free to subscribe to the channel. It definitely helps me trying to grow this channel. And if you know anyone else who's interested, please feel free to spread the good word as well. And as always, thank you very much for your time. Take care and bye bye.